Hello everyone, thank you for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Tot. And welcome to SAT ACT Prep. Today we're going to start talking about the operations with values containing radical signs. So just as if subtraction is the opposite of addition, just as division is the opposite of multiplication, rooting, which is symbolized by the radical sign, is the opposite of exponentiation, which is raising something to a power. Now, a lot of students get intimidated by problems containing operations and radical signs and different indices. However, I want to disabuse you of that anxiety a little bit. Awesome, thank you, Mark. Thank you very much for letting me know about the audio. Yeah, we've been having some audio issues for some reason. Sometimes it works and sometimes it doesn't. I don't know why. But great, I'm glad that it is. But I want to disabuse you of the anxiety of working with radicals because actually the rules that govern operations with radicals are very similar to the rules governing operations involving fractions. When we add or subtract fractions, we need to have a common denominator. Once we have a common denominator, we keep the denominator, add or subtract the numerator. With radicals, you need a common radicand. A radicand is the number underneath the radical sign. Once you have common radicals, once you have common radicands, you add or subtract, you keep the radicand, add or subtract the coefficient. So they're kind of similar in that regard. Also with multiplication and division. With fractions, when we multiply fractions, we just go straight across, right? Numerator times numerator over denominator times denominator. With radicals, it's pretty similar. You just go part for part. So radicand times radicand, coefficient times coefficient. But they're pretty similar, and we're going to go through some examples today. Today will be an introductory lesson, and then we'll get into some more complicated SAT questions on Wednesday and Friday. Let me go ahead and share my screen with you. And also I updated the watermark, so if you have not yet, I would invite you to subscribe to my channel. You can just click the watermark in the lower right hand corner, and that's like a shortcut. But, okay. And I do apologize because we're going live and it's during the time of day. A lot of people are using the internet right now. The iPad does have a little bit of a delay, so I'm working with that and I'm trying to adjust my speech and tenor to match it, but I do apologize in advance if it's a little bit slow. So the overarching theme when we're talking about radicals and rules pertaining to radicals, like I said before, is that they're very similar to fractions. So we can use the rules of fractions as a bridge or as a memorization device to remember the rules of pertaining to radicals. And just some definitions. So if we had a number like 2 root 3, the 2 here is going to be the coefficient. This is called the radical sign. And the 3 is the radicand. And that's just the value that's underneath of the sign itself. Now, when there isn't an indice or a little number that's on top of the radical sign, it's implicitly the square root. So just like when we write x, we really know that that implies that it's 1 times x, or that there's a coefficient of 1 in front of the x. And really, if you wanted to be super specific, that's really the same thing as 1x to the 1 power. The problem is that the 1s don't do anything. They're inconsequential to the value itself, because 1 times anything is that same something. 1 anything raised to the first power is that same something. So in mathematical nomenclature, we just avoid writing the 1 because it's useless, because we can just impute the fact that, or assume the fact that it has a coefficient of 1. The same thing is true for the radical sign. When we don't have an index value, it's implicitly 2. So I'm going to write in there in blue an index value of 2. But when we don't see it, it's implicitly the square root. But it could also be the cube root, the quartic root. You could take the 5th root, the 7th root, the 8th root, the 6th root. All of those, an infinite number of roots apply here. So, but when it's not listed, then you can safely assume that it's 2. But otherwise, that little number on the radical sign is called the index value. If there's any questions, then just let me know. So this number would be, you would read this as 2 root 2. The radical sign in math is called root. So you read it out as the square root. You could say the square root or just root. If it had an index value of 3, you could say the cube root. If it had an index value of 4, another complex name for that is the quartic root. But any other power after 4, or really after 3, we just say like the nth root, so like the 6th root, the 10th root, the 20th root, so on and so forth. Okay, so this brings us up to the first rule, and we're going to talk about adding or subtracting values with the radical sign. So in order to subtract or add or subtract values with radicals, you have to have common radicants. So the number underneath the radical sign has to be the same in both problems, or else you cannot simplify or combine them. Once you have common radicants, then you keep the common radicant and add or subtract the coefficients. So for example, let me just write out a few here. So first example, let's look at 2 root 3 plus 5 root 3. And then we'll also look at 5 root 2 minus 4 root 2. So with 2 root 3 and 5 root 3, they both have common radicants. So they both have a root 3. So we keep the root 3 and we add or subtract, in this case add, the coefficients. So that's going to become 2 plus 5 times the square root of 3, which would simplify into just 7 root 3. Similarly, the same thing is true with subtraction. In the second example, we have common radicants of 2. So we're going to keep the common radicant, add or subtract the coefficient. So the second example is going to turn into 5 minus 4 times the square root of 2. Notice that that's going to turn into 1 root 2, which is the same thing as just root 2. If you have any questions, just let me know. I just want to make sure that the iPad catches up to me. But if not, feel free to drop them in the live chat function or in the comments section below if you're watching the recording. Let's look at these two examples. So I'll give you 3 minutes. I'd like you to add or subtract the following radicals. We have 3 root 2 plus 2 root 2, and we have 6 root 3 minus 5 root 3. I'll keep track of the time in the upper right-hand corner and update it per minute. Okay, so looking at number 1, we have a common radicand of 2, so we're going to keep the common radicand of root 2, add or subtract the numerators, add or subtract the coefficients. So we're going to have 3 plus 2 times the square root of 2, which is going to end up being 5 root 2. Number 2, we have 6 root 3 minus 5 root 3. So we still have common radicands. Both of them are root 3. So we subtract the coefficients of 6 minus 5. 6 minus 5 is 1, so we have 1 root 3. But in math, we usually won't write the 1 as a coefficient. So our answer here is just going to be the square root of 3. If you have any questions, then please let me know. Otherwise, I'm going to give you 2 minutes. I'd like you to look at the next 2 problems. We have the square root of 5 plus 2 root 5. And then number 4 is 7 root 7 minus 2 root 7. So I'll give you 2 minutes, and I'll keep track of the time again in the upper right-hand corner. Okay, so number 1 with root 5 plus 2 root 5, that's really 1 root 5 plus 2 root 5. So keeping the common radicand of 5 and adding the coefficients, we're going to get 1 plus 2 times the square root of 5. And 1 plus 2 is 3. So your answer to number 1 is going to be 3 root 5. For number 4, same type of thing. We have common radicands of 7. So we can subtract the coefficients. And 7 minus 2 is going to give us 5 root 7. If you have any questions, then please just let me know. Otherwise, let's look at 5 and 6. So with 5 and 6, I do want to mention a new strategy. It's going to be the same type of thing, but now you can see we don't have common radicands. Remember, we can't do any of the operations that we talked about before with subtraction or addition without common radicands. So we need to be able to simplify here. If I had the value, the square root of 24, remember that with this index value of 2, whenever it's the square root, the index value is 2. That means that for every 2 factors that are underneath the radical, 1 factor can come out. So just like we were taking just like we were factorizing values in our lessons on the LCM and GCF, we can break this guy down into prime factors. So notice that 24 is divisible by 4 and 6. 4 is divisible into 2 and 2. And 6 is divisible into 2 and 3. So by factorizing this value, we've broken it into its prime components, all of the prime factors that make up this composite number. So the square root of 24, for example, is the same thing as 2 times 2 times 2 times 3. And for every 2 underneath, you can bring 1 outside. So the square root of 24 would reduce into 2 times the square root of 2 times 3, which would simplify further into just 2 times the square root of 6. So for every 2 underneath, because the index value is 2 here, you can bring 1 outside, and so that becomes 2 times the square root of 2 times 3, or in other words, 2 times 6. This is going to be important in the next 2 problems because you might need to simplify in this manner in order to first convert into common radicands, so then you can actually do the operations of adding or subtracting. Okay, I'm going to give you 3 minutes. Actually, I'm going to give you 4 minutes. This involves a little bit more. So let me give you 4 minutes, and then I'll go through the solutions. Remember that you first need to get common radicands. The numbers underneath the radical signs must be the same if you want to add or subtract the coefficients. Okay, so let's look at these. I started to do some simplification here just while you were working, just to get you started. So remember, we have to have common radicants in order to add or subtract any value with radicals. So the first step is to simplify these guys into common radicals. So the square root of 27, I did that right here. So notice that if we broke down 27 into its prime factorizations, then, and I can make this a little bit bigger because I just did this for space. So notice that 27 breaks down into 3 and 9. 3 times 9 is 27. 3 is prime, and 9 breaks down into 3 and 3. So the prime factorization of 27, or the square root of 27, is the same exact thing as the square root of 3 times 3 times 3. And because we have the square root here, for every 2 underneath the radical, we can take 1 outside. And so the square root of 27 factors or simplifies into 3 root 3. So instead of 27, or excuse me, instead of the square root of 27, I can write 3 times the square root of 3. Now you still have that coefficient of 3 on the outside right here, so you can't forget that. But then we also have this coefficient of 2, and that's from this guy right here. But similarly, the square root of 12 breaks down into a prime factorization of 3 times 4. 4 breaks down into a prime factorization of 2 times 2. So the square root of 12 is the same exact thing as the square root of 2 times 2 times 3. And for every 2 values underneath the radical, we can pull 1 outside because it's the square root. Now, if it was the cube root, you would need 3 values underneath the radical to pull 1 outside. If it was the quartic root, or if it was the index value was 4, you would need 4 values underneath the radical sign to pull 1 outside, and so on and so forth. But here we have the square root, so we can pull 1 2 outside of the radical because we have 2 2's underneath of the radical. Oops, I'm so sorry that my iPad stopped broadcasting. I'll fix that in a second. So the square root of 12 is the same exact thing as 2 times 2 times 3, which will simplify into just 2 root 3. So on the right-hand side here, we're going to have 2 times the quantity, 2 root 3. And we could just distribute there. Let me get this guy out of the way now. Oh. So if we distribute those coefficients, now we're going to have 9 root 3 plus 4 root 3. We have common radicals, so we keep the we have common radicants. So we keep the radicand, add the coefficient. 9 plus 4 is 13. So this final answer is going to be 13 root 3. If you have any questions, please let me know. Number 6, we have 2 times the square root of 50 minus 2 times the square root of 18. As they're written, we have subtraction of radicals, but we don't have common radicants. We can't do anything to this unless we have common radicants. Let's go ahead and look at the square root of 50 that I did in blue down here. So notice that the square root of 50 is the same thing as 2 times 5 times 5, or the square root of 2 times 5 times 5. Because 50 reduces into 5 times 10, 5 is prime, but 10 is not. 10 breaks down into 2 times 5, so the prime factorization of 50 is 2 times 5 times 5. Because this is the square root of 50, we can rewrite that as the square root of 2 times 5 times 5. Because there's two 5s underneath the square root, we can pull one 5 outside for every 2 underneath. And so this is going to turn into 5 root 2. So we're going to have 2 times 5 root 2. Because remember, oops, sorry about that. Because remember, this 2 is still carrying through from that coefficient. That outside coefficient has to remain intact. Now we're subtracting from that 2 times the square root of 18. If we evaluate, or if we simplify, oops, I didn't want to do that. If we simplify the square root of 18, as I did down here in purple, you can see that 18 breaks down into 3 times 6. Oops, I'm sorry, you can't really see that. Let me move that up a little bit. So 18 breaks down into 3 times 6. 3 is prime, but 6 breaks down into 2 times 3. So the prime factorization of the square root of 18, or the prime factorization of 18 is 2 times 3 times 3. So the prime factorization of the square root of 18 is 2 times 3 times 3, the square root of 2 times 3 times 3. For the 2 3's underneath the radical, you can bring 1 outside, so this will simplify into 3 root 2. So instead of writing the square root of 18, we can just write 3 root 2. Distributing that coefficient, and just to be clear, that 2 comes from this 2 right here. We can distribute those coefficients inside the parentheses. Remember that they're not going to affect the radicand. They're not going to affect the values underneath the radical sign, just the coefficients, just the numbers outside of the sign. So we're going to have 2 times 5, which is 10, so 10 root 2, minus 2 times 3, which is 6, so we'd have 6 root 2. 10 root 2 minus 6 root 2, keep the common radicand, add or subtract the coefficients. 10 minus 6 is 4, so we're going to have 4 root 2 as an answer. If you have any questions, then please let me know. Otherwise, I'm going to give you 4 minutes. I'd like you to look at the next 2 questions, questions 7 and 8. So we have 3 times the square root of 20 plus 2 times the square root of 45. I'd like you to simplify that. And number 8 is 3 times the square root of 54 minus 2 times the square root of 24. Notice I read those a little bit differently, but they are exactly the same statements as I said before, as we were saying before. We could also say this. Number 7 is 3 root 20 plus 2 root 45. And 8 we could also say as 3 root 54 minus 2 root 24. I'll give you 4 minutes, and then I'll give you the answers, more than one. Okay, so looking at number 7, we have 3 root 20 plus 2 root 45. So I started to simplify those radicals there while we were working. So root 20, we can simplify that, break 20 down into 4 times 5. 5 is prime, but 4 breaks down into 2 and 2. Actually, I'm sorry, let me make some room here so I can bring this up while I'm talking about it. Here you go. So here's the factorization of 20. So it breaks down into 4 times 5. 4 breaks down into 2 and 2. So the square root of 20 is the same thing as the square root of 2 times 2 times 5. And so for the 2 2's underneath, you can bring one of them out. And so this will simplify into 2 root 5. So instead of writing the square root of 20, I can just write 2 root 5. So this is going to be 3 times 2 root 5 plus 2 times. And now if you see the square root of 45, so 45 will break down into 5 times 9. And 9 will break down into 3 times 3. So the square root of 45 is the same thing as 3 times 3 times 5. The 2 3's underneath the radical, you can pull 1 out, so it would become 3 root 5. Distributing within the parentheses, the coefficients outside the parentheses will only affect the coefficients that are inside the parentheses, not the radicants. 3 times 2 is 6, so we're going to have 6 root 5, plus 2 times 3 is also 6, so we're going to have 6 root 5 plus 6 root 5, so that's going to give us 12 root 5. For number 8, we have 3 times the square root of 54 minus 2 times the square root of 24. So the square root of 54, we can factorize that. That's going to break down into 6 times 9. 6 breaks down into 2 times 3. 9 breaks down into 3 times 3. So the factorization of 54 is 2 times 3 times 3 times 3. So for the 2 3's, for one pair of 3's underneath the radical, we can pull 1 3 outside of the radical. So, but we still have left under one of the 3's. So notice that sometimes that can happen, that not all of them will eliminate. And I'm sorry, my iPad just keeps on disconnecting there. But we're left with 3 times 2 times 3. So that's going to be 3 times the square root of 6. So instead of writing 54, I can write 3 times the square root of 6. So this is going to turn into 3 times 3 root 6 minus 2 times, now 24, I think my camera's in the way of it here. If I bring that up, so 24 can be broken down into 6 times 4. 6 breaks down into 2 times 3, and 4 breaks down into 4 times 4. So the square root of 24 is the same exact thing as the square root of 2 times 2 times 2 times 3. For one pair of 2's, I can bring one 2 out for one of the pairs of 2's underneath the radical. And so the square root of 24 is going to simplify into 2 times 2 root 3, which is 2 root 6. And so we're going to end up with 3 times 3 root 6 is 9 root 6. 2 times 2 root 6 is 4 root 6. Once we have common radicants, we keep the radicand, add or subtract the coefficients. And so we're going to end up with 5 root 6. let me just make sure that my screen is broadcasting correctly. So if there's any questions on 7 and 8, I'm sorry, I had to reconnect my iPad there. It's giving me some trouble today. I don't know. Sometimes it wants to cooperate, sometimes it does not. So I don't know what's going on. So my apologies. I'm trying to get it closer to the Wi-Fi if I can. But the answer to number 7 was 12 root 5. The answer to number 8 was 5 root 6. And if you have any questions, then please let me know. This takes us up to multiplying or dividing values with a radical sign. So just like with addition and subtraction, the rules with multiplication and division are very similar to those of multiplication division with fractions. To multiply or divide values that have a radical sign, you need to multiply coefficient times coefficient, and then radicand times radicand. So it's also important to know, I don't know if my screen, all of a sudden my screen's not moving. I'm moving my iPad screen. But now the broadcast screen doesn't want to move. My apologies, guys, 1 second. Give me 1 second. I'm going to increase my camera for 1 minute while I disconnect my iPad. Because it should be on another screen. I have the multiplication screen up and it's still on the last value of the last problem set where we were adding or subtracting. So let me just see if I can get this going correctly. And let me see if it moves. If it moves, then we're golden. Doesn't want to move. So I might have to reconnect and connect again, but I hope that this works. Anyways, let's try and continue and hope. Oh, there we go. Okay, so it's moving. Sorry, it's just a little bit delayed today. Must be a lot of people using the bandwidth. Okay. So to multiply or divide, we just go straight across as in fractions. So in fractions, it would be numerator times numerator over denominator times denominator. With radicands, when we multiply, it's coefficient times coefficient, radicand times radicand. And the same when we divide. Coefficient divided by coefficient, radicand divided by radicand. And it's also important to note here that you do not need to have common bases in order to multiply or divide by radicals, or multiply or divide radicals into each other. If you have any questions, then please let me know. Otherwise, I'd like to take a look at problems 1 and 2. So remember, coefficient times coefficient, radicand times radicand, and then if you can simplify the value underneath the radical by factorizing, you'd want to do that as well. So I'm going to give you 3 minutes. I'd like you to give these 2 problems a try, and then I'll give you the solution. Okay, so number 1 is 3 root 6 times 2 root 2. So we're just multiplying straight across, coefficient times coefficient, radicand times radicand. So we're going to have 3 times 2 times the square root of 6 times 2. 3 times 2 is 6. 6 times 2 is 12. Now, that is the final answer, or that is the answer here, one answer. However, it's not in simplified form. So we want to simplify that radicand of 12 by factorizing it into 3 times 2 times 2. Noticing that there's 2 factors of 2, or 2 divisors of 2 underneath the radicand, or I should say included in the radicand. So we can pull 1 2 out for every pair of 2's underneath. That gives us 6 times 2 times the square root of 3, which would ultimately lead us to a final answer of 12 root 3. For number 2, 4 root 15 divided by 2 root 3. So again, just dividing the coefficient by coefficient and radicand by radicand. 4 divided by 2 is 2. 15 divided by 3 is 5. So this is going to end up simplifying into 2 root 5. If you have any questions, then please let me know. Sorry, didn't mean to scroll up there. The next 2 problems, we have the square root of 2 times 7 times the square root of 5. And question number 4, 9 times the square root of 10 divided by 3 times the square root of 5. I'm going to give you 2 minutes, and then I'll give you the solutions. Okay, so for number 3, remember that whenever we just have the square root of something, the coefficient is implicitly 1. So the square root of 2 is really 1 root 2 times 7 root 5. So we're going to have 1 times 7 times the square root of 2 times 5. So 1 times 7 is 7. 2 times 5 is 10. So we're going to have an answer of 7 root 10. Number 4, we're going to divide coefficient by coefficient, radicand by radicand. So we're going to have 9 over 3 times the square root of 10 over 5. 9 over 3 is 3. 10 over 5 is 2. So our final answer here is going to be 3 root 2. If you have any questions, then please let me know. The next problems are going to involve some simplification, so it's the same type of thing, but you're also going to need to simplify because the radicants are going to be larger than before. But you're going to apply the same exact process. It's just coefficient times coefficient, radicant times radicant, or coefficient divided by coefficient times the radicant divided by the radicant. So, question number 5 says 5 times the square root of 12 times 2 times the square root of 6 is equal to what? And you're going to have to simplify there into a final form. So you're going to have to factorize your answer, the radicant of your answer, that is. 6 is 24 times the square root of 48 divided by 8 times the square root of 6. So I'll give you 3 minutes, and then I'll give you the answer. Because of the delay in the iPad, I think it's better if I just start solving, so then we don't have to wait for the thing to catch up. But if that's distracting, or if you have any other recommendations, then I'm all open to your opinions and suggestions. But otherwise, I'll give you 3 minutes, and you may begin. Okay, so looking at 5 and 6. So 5 times the square root of 12 times 2 times the square root of 6. We're going to have coefficient times coefficient, radicant times radicant. So that's going to be 5 times 2 times the square root of 12 times 6. So that's going to give us 10 root 72. 72 we can factorize. I did that down below to the left. 72 breaks down into 6 times 12. 6 breaks down into 2 and 3. 12 breaks down into 3 and 4. 4 breaks down into 2 and 2. So 72 is the same thing as 2 times 2 times 2 times 3 times 3. So notice we have 2 pairs of 2 and 2 pairs of 3. So I can pull 1 2 out and 1 3 out. So this ends up being 10 times 2 times 3 and leaving 1 2 in the radicand. So we have 10 times 2 times 3 times the square root of 2, which is going to end up giving us 60 root 2. For number 6, we're going to do coefficient divided by coefficient, radicand divided by radicand. So 24 divided by 8 is 3. 48 divided by 6 is 8. So we end up with 3 root 8, but we can simplify root 8 because 8 breaks down into 2 and 4. 4 breaks down into 2 and 2. So we can pull 2 2's from underneath the radicand and pull 1 2 out. So it's going to be 3 times 2 times the square root of 2, which is going to ultimately simplify into 6 root 2. If you have any questions, then please let me know. Otherwise, let's take a look at the next 2 problems. So I'm going to give you 2 minutes. I'd like you to look at questions 7 and 8. So 7 says 8 times the square root of 15 times 7 times the square root of 6 is equal to what? 8 says 18 root 120 divided by 9 root 3. And I'd like those answers in simplified form. So if you get a radicand that can be simplified, please go ahead and factorize the value into simplified form. I'll give you 2 minutes. Actually, I'm sorry, I'll give you 3 minutes. That's a little bit much, right? I'll give you 3 minutes, and I'll give you the solution. Okay, so looking at number 7, 8 root 15 times 7 root 6. So we're going to have 8 times 7 times the square root of 15 times 6. That's going to turn into 56 root 90. We can factorize 90 into 9 times 10, and 9 breaks down into 3 times 3, and 10 breaks down into 2 times 5. So the square root of 90 is going to be 2, the same thing as the square root of 2 times 3 times 3 times 5. So we have a pair of 3's underneath the radical. We can pull 1 out for that pair. So it's going to turn into 3 times 56 times the root of 2 times 5. 3 times 56 is 168. 2 times 5 is 10. So our answer is going to be 168 times the square root of 10. For 8, we have 18 root 120 divided by 9 root 3. 18 divided by 9 is going to give us 2. The square root of 120 divided by 3 is equal to the square root of 40. 40 will factorize into 4 times 10. 4 breaks down into 2 times 2, and 10 breaks down into 2 times 5. So the square root of 40 is the same thing as the square root of 2 times 2 times 2 times 5. So we have a pair of 2's underneath the radicand, or underneath the radical rather. We have a pair of 2's in the radicand, and we have a pair of 2's under the radical, is how you correctly say that. So we can pull 1 pair out, so we'd end up with 2 times the square root of 2 times 5, which is ultimately, which is ultimately going to give us 4 times the square root of 10. If you have any questions, then please just let me know. Otherwise, let's go on. So now let's talk about rationalizing the denominator. Sometimes in math problems, especially in the SAT, they're going to ask you, they're going to give you a problem in which that will lead you up to a step where you have a radical in the denominator. But when you try and check that answer against answer selections that they give, it's not going to match because they've rationalized the denominator, meaning that they did not include a radical sign in the denominator at all. So you need to know how to be able to do that. So you should not, technically in math, you should not leave any value with a radical sign in the denominator. In order to remove the radical sign, you're going to multiply by a fraction equivalent to 1, where the numerator and the denominator are both the radical portion of the value itself. So for example, if I had 5 root 5 divided by 2 root 3, I can rationalize this denominator by multiplying by root 3 over root 3. Notice that root 3 over root 3, that's something divided by itself, and that's going to be equal to 1. So if you multiply by some fraction with the same thing in the numerator and denominator, then that's the same thing as multiplying by 1, which is not technically going to change the value itself. It's just manipulating the numerator and denominator relative to each other. So if I multiplied this through, this is going to end up being 5 root 15 over 2 times 3. Notice that root 3 times root 3 is the same thing as root 3 squared. And so the square root and the square will eliminate, leaving you just with 3. So the final answer here, you're going to have 5 root 15 over 6. So if I rationalize that starting value of 5 root 5 quantity divided by 2 root 3, then in rationalized form, that's exactly equivalent to 5 root 15 divided by 6. If you have any questions, then just let me know. And we're only going to be able to probably get through one of these problems, but we'll pick back up with this on Wednesday. Hopefully on Wednesday my iPad is a little faster too. Today it was really, really slow. I'm just looking at the screen. That's why I'm kind of like pausing every once in a while. I'm trying to make sure that my iPad is not too far behind. So I do appreciate your patience. Sometimes the internet likes to work and sometimes it does not. But again, if you have any questions, then please let me know. Otherwise, let's look at this first problem that'll take us up to the end of class today. So question number 1, we have 2 times the square root of 2 quantity plus 2 all over 8 root 3. So in the numerator, we have a binomial, and you'll see that as soon as my iPad catches up with me here. But we have a binomial. We don't have any variables, but we have 2 expressions that can't combine as they're written. So you have to treat them as if they're bound to each other. You can't just divide into one without dividing into the other. And as it's listed here, we have a radical in the denominator. So rationalize this denominator by multiplying by some fraction equivalent to the radical portion of the denominator in both the numerator and denominator itself. So I'll give you 3 minutes. Okay, so with this problem, 2 root 2 plus 2 divided by 8 root 3, I'm going to rationalize that denominator by multiplying by root 3 over root 3. Remember the golden rule in mathematics, you have to do to the left side of the equation as you do to the right. You have to do to the numerator whatever you do to the denominator. But as long as you do everything, you do the same thing to both sides, or if you're talking about like a multi-sided inequality, you do the same thing to all sides, you can almost do anything that you want in math. There's a few rules, like you can't divide by 0, you can't take the square root of a negative number. There's a few other ones too in the more advanced math courses we'll get to. But you have a lot of options here, and you just have to make sure that you do the same thing to both sides. So if I multiply the denominator by root 3 in order, in aim of eliminating that radicand of root 3, then I have to make sure that I multiply the numerator by root 3. In doing so, I have two factors, two values in the numerator. I have 2 root 2, and then I have just 2. So I have to make sure that that root 3 is distributed to both values in the numerator. That's a big mistake that a lot of students make. So you have to apply it equally to both values in the numerator. When I do that, I'm going to get 2 times the square root of 2 times 3 plus 2 root 3 in the numerator. In the denominator, I'm going to get 8 times root 3 times 3. In the numerator, that will simplify into 2 root 6 plus 2 root 3, quantity divided by 8 root 9. The square root of 9 is in fact 3, so we can evaluate it as such. So 2 root 6 plus 2 root 3, quantity divided by 8 times 3. 8 times 3 is 24, so our problem is going to turn into 2 root 6 plus 2 root 3, quantity divided by 24. Now I can simplify further by pulling a 2 out of the numerator and denominator. But this is another really careful step, another really subtle step that you have to be careful about. You need to make sure that you pull the 2 out of both values in the numerator. You can't just go at it with one value. If the values in the numerator are, or if any value, if values are separated by addition or subtraction, you have to think of them as being like married to each other, being bound to each other. And so if you want to pull something out of one, you have to be able to pull it out of both. Both values here, the 2 root 6 and the 2 root 3, have coefficients of 2, so I can safely pull a 2 out, meaning that I have 2 times the quantity root 6 plus root 3. And similarly, I'm pulling a 2 out of the denominator of 24, so I just rewrote 24 as 2 times 12. And then you can see that the 2's in the numerator and denominator are common factors, so they can eliminate, leaving us with a final answer of root 6 plus root 3, quantity divided by 12. If you have any questions at all, then please let me know. But otherwise, I hope that this was helpful. If you're not already, please go ahead and hit that watermark and subscribe to my channel. But we'll pick back up with this on Wednesday and Friday with some more problems, and we'll also look at some equations, solving equations that have radicands that are variables, and also some more simplification problems. But otherwise, I am Mr. Matt. This has been SAT, ACT Prep. This is Dr. Tot. Dr. Tot, do you want to say goodbye to everybody? Come here. Can you give me paw? You say bye to everybody? Okay, good boy. All right, thank you guys very much for signing in. I'll talk to you all tomorrow. Tomorrow's reading. And then we'll continue this lesson on Wednesday. Have a great day.